Hello, this is CIT 371, Linux System Administration. Today, I'm going to talk about bash scripting. So, I do want to note that these modules, or this module for scripting, is a little different. The lectures here are going to be a little different, where I'm not going to exactly give an overview of the labs, but I'm going to provide some more in-depth information. So, I understand scripting is very difficult for a lot of people, and honestly, I am the same way. I'm not the best programmer in the world, but I know enough to get by for like what I do in my job. So I want to provide a little more in-depth information to make sure you all have enough information to do well in these labs. They're not very hard, but I do want to provide everything you need to be able to succeed here and learn how to script. So I'm going to provide some more in-depth information in this and the next lecture for this module. So I will just give you an introduction to Bash. I'm going to specifically talk about how to script, like how to write scripts and stuff. Then I'm going to provide some basic scripting constructs. So I'm going to talk to you about the various, I guess we call them constructs that are used in scripting, like how to write a for loop, how to use if statements, how to use comments. All those things will be discussed in this lecture. So by the time you're done with this one, you'll know how to write scripts. Well, the following lecture is going to give some in-depth examples of how to go about writing scripts. So, teach you the basics that you need to actually write scripts, but how to know what to use, how to use these constructs, or when to use them will be covered in the next lecture. One other thing before I begin, please make sure you look at the supplementary materials for this lab because there's a lot of really helpful information. I think you will have, if you use the lecture I provide and you use the supplemental materials, you're going to have a much easier time in these scripting labs than if you would not use them. Okay, we're going to talk about Bash. So Bash, otherwise known as the Born Again shell, is a command language and shell program that is used by default on the vast majority of Linux and Unix systems. So Bash is actually a newer version of what has come before it. So it's interesting. A friend of mine actually was working on a really old Linux server, and it was not Bash. It was something called Corn Shell. It actually didn't have a lot of commands and features that Bash does. So I know some of us kind of struggle with the terminal, but let me just let you know, it could be worse. You could have less commands and less easy ways of doing things. Bash has a number of commands and variables and other features that a number of previous terminal environments in Linux did not have. So I will note that a shell is a macro processor that is utilized to execute commands on an operating system. So basically, it gives you a shell as a way for you to interact with the system with commands. So Bash, the main feature of Bash is allowing you to run programs, but it also allows you to use these commands as a programming language to automate system administration tasks. So it's important to note when I'm talking about Bash, it's not just a terminal, but it can also refer to a programming language, a system programming language for Linux. I will say I've attached here a Bash reference manual. Pretty in-depth information on Bash. You don't really need to know everything here for this class, but if you want to learn more, I provided it for your reference. So, I want to talk about how to script for Bash. Now, this is going to be very important because you're going to need to know this for the next two labs. To write a script in Bash, the first step is to open a new file with the text editor. I recommend Nano, but if you want to use Vi, that is completely up to you. I recommend Nano. So it's important to note when you name this file, you need to end its name with .sh. So for example, my underscore first underscore script.sh is an executable script. It is a bash script file with the proper file extension at the end. Now after you open the file, the first thing you need to do is add a shebang in your interpreter. So a shebang is basically a hashtag and an exclamation point, followed by the absolute path of the interpreter using. The bash is located in /bin/bash. So the first line of every script you write needs to be hashtag, exclamation point, /bin/bash. That needs to be at the top of every script you write, or bash script you write. So after that, you write your code. We're going to talk about that part for the rest of the lecture, but After you write your code, you save the file, then make it executable with the command command. So the thing of this has got to be permission 755. So the number 5 means read and execute. So you need to make sure you put 5 for the other two numbers of your script permissions. Then there's running the script. Now, if you're in the same directory as the script, you write period slash then your script name. That is how you run a script in Bash. So that's basically the process you're going to be repeating for these next two labs. I provide a screenshot here. Just going to provide some descriptive audio here. So we're in a SSH connection from my terminal. I've opened a script called my_first_bash, or excuse me, script.sh. I'm in nano. The first line of the file is hashtag !bin/bash. It is that is the shebang there. Then I have a little comment. So I start a comment with the hashtag, put a space, and then write my message. So the hashtag in front of this comment keeps it from being executed, so you can explain to people, or you can write full sentences that people can use to understand what your program does. So I say write out a message. Then I use the echo command, and then between quotation marks I write, this is my first script. So now I'm saving the file. I've hit Control X in nano. I can now hit Y to save it, and then press Enter to save the name my_first_script.sh. Now in my terminal session, I ran chmod, chmod, then 755, my_first_script.sh. So as I was saying, the 755 permission is necessary for the script to run. Now finally, I've typed period slash my first script. So I'm running the script now, and all it does is run that echo command in the file. This is my first script, so I can run, instead of having to type out that message, I can just run this command here. Run the script here, and it'll just print the message for me. Now, it's very simple. It really doesn't do anything of much value, but scripts can do a lot more than this when you learn how to program or script correctly, Bash. Okie dokie. Now it's time to go over the script basics of Bash scripting. So a lot of Bash scripts that you're going to write are just going to be writing out commands that you want to run in a sequence. Now there are many scripting features that you can use to improve how you run the commands and when they are run. So the following slides are going to teach the basics of Bash scripting that you're going to need for this course. We have a lot of topics to go over, including comments, variables, quotation marks, escape sequences, show command execution, user input, if and else statements, for and while loops, case statements, and functions. Now, I know it's a lot, but I'm going to go over it pretty quickly. Now, there's even more Bash scripting concepts beyond this, like modules and other things, but we don't need that in this class. I do have a Bash scripting tutorial article from Linux Config in the supplemental resources page. I can recommend that if you want to go a little more in depth, but I've included what we really need for this class. Comments. I'm going to just go over this quickly. So basically a comment is just a bunch of sentences. It's one or more sentences that you include in your script to just explain how it works and what the purpose of the lines it's above is, or lines the comment sits above is. So a single line comment is done or is written out by putting a hashtag in front of your line. Like you can do hashtag space this line prints a message to the screen. And then under we have an echo command that just prints out hello CIT371 class. It should be noted that you can actually put comments right after your command. So you can write up this echo command and then put a comment right next to it that says print a message to the class. Now you can also write multi-line comments. Now you can either start each line with a hashtag or use a colon and single quote as I've shown below. So I put a colon, space, a single quote, and then I could put multiple lines of messages or a multi-line message under that. I've written this purpose of this program is to print the message that greets the class with a friendly message. And then I press enter under that and then put another single quote. So that allows for a multi-line quote or comment without having to put a hashtag on each line. So variables are memory locations that allow you to store data for future and repeated use. You can kind of think of a variable as a box holding some object. And you can actually change what's in that box throughout the script. So to create a variable, you place an equal sign right next to the name that you're making for the variable. And then you type a string of characters in quotes right after it, or you type a number that doesn't need to be in quotes. It should be noted that there are data types to be specified, which I'll get into just a little bit. So I have a variable here. It's called message1. So it's just going to be a message. Message1, no spaces in between the equal sign and the variable name, and then there's no space between the value in the variable and the equal sign. So you type message1 equal sign and then this message hello CIT371 class. Note that there's no space here. That's going to be very important for you to know in your lab. Now here's something interesting here. Class underscore size equals 20. There's no quotes around the number 20. That should be noted. It should be noted here when you're using a numeric value in your script. You don't put it between quotes. Quotes note that you're writing a string, which is basically a sequence of characters that typically are used to write a message or write a name. It's just a word, basically. Strings are words, generally. When you don't have quotes around your variable, it is a number to use it for mathematical operations such as adding or subtracting and so forth. So when you want to use a variable, you have to put a $sign before it. So I can type echo message1, and it'll print hello CIT371 students. Then I can print echo another message. This class has, and I have class size, students in it. So it'll just print 20. This class has 20 students in it. And it'll pull the value from class size here. You can also write your variables in all caps or lowercase. You can also do the camel case where your variable is multiple words. You don't put spaces between the words, but you separate them by capitalizing every subsequent word after the first one. It should note that programming languages generally have variable type, but Bash does not. Generally, most variables are treated as strings. So in other words, they're groups of characters with no numerical values. But like I said, if you don't put a number inside quotes, it could be used in mathematical contexts. So quotation marks, this is something kind of important to know. So single quotation marks and double quotation marks can both be used to enclose a string of characters in a message or variable. However, you should note that they do function a little different from one another. So it's important to note when you should use single quotation marks versus double quotation marks. Now, single quotes will cause special characters to be read as they are. In other words, if you print out a string variable enclosed in single quotes, characters such as a $sign, forward slash, or other characters will be printed out inside the message. Note that this prevents you from printing out variables in a message. So in other words, if you use single quotes and you have a variable in your message, the $sign is going to be taken as just a character to print out, not as a special character that's going to be used to call a variable. So therefore, if we go back here and we if we printed this message in single quotes, it would just say this class has $sign class size students in it. If you do double quotes, it'll actually allow the $sign to be a special character and call the numeric value here. So we can get this class has 20 students in it. Double quotes will cause special characters to function as meta characters. So in other words, a meta character, like I was just saying, is a character like a $sign that has a special feature or function. So I'd say generally, unless you really want to print out a $sign in your message or something, make sure you use double quotes. So I'm going to talk a little bit about escape sequences. So this is a sequence of characters that allow you to output certain characters you otherwise could not in Bash. Generally, this is just used to input or insert white space, such as tab spaces or new lines, in your output, like when you're running echo messages. There's a pretty big list of this on the internet, but the only ones you need to know for this course are /n to create a new line, and /t to create horizontal tab spaces. Now this is important for the lab, just to let you know. Bash scripting part 1 requires you to be able to use these. So escape sequence is applied to the text that comes directly after it. To use escape sequences, however, with the echo command, you got to use the -e option. I'm going to show this in an example here. So say we're printing out a list of fruit. We're going to start with echo fruit. That line's not tabbed, but we want everything under it to be tabbed, to be like a list. So for the remaining for the fruit in this list, we're going to type out echo -e to support the escape sequence characters. Now we use /t to tab out each item, such as an apple, banana, and pear. So this makes your list a little. It's just really for nice formatting. That's what escape sequence characters like these two are used for. Shell command execution. Now, unlike other programming languages, the Bash scripting language allows you to directly type out operating system or shell commands in your script. So in other words, like the commands you're running in your terminal, you don't if you were using Python, you would actually have to use a specific, if I'm correct with the terminology, you have to use a specific module like the OS module to be able to support shell commands. Bash, you don't need to do that. You can just type out a command without any strings attached. Um, so let's see here. Now, there is an exception to bash, however, when you want to store the output of a command and save it for later or reuse it multiple times. So if you want to store the output of a command in a variable, you have to enclose your shell command and within parentheses and precede that with a $sign. So for example, let's say we wanted to get the date in a variable called time. We type time equals $sign first or opening parentheses date closing parentheses. And then when we want to access data, we type echo $time and put that variable between double quotes. Now, user input. There are times where you want to receive user input when you're running a script. Like you want the user to provide a value when you're running a variable. You want to put in a variable. The read command is used for this, which waits for the user to type in a response and enter it. So you can just type in the read command if you really want to, without context. But it's generally recommended that you print out a message to the user to let them know, he or she know what you want. So this is an example of how to do this. So we have echo, please provide your name. Then you type read name, which is the name of the variable you're getting. And echo, hello name. So that's how you get user input in Bash. We're going to talk a little about if statements. There are times where your script will need to make a decision to know whether or not to run certain lines of a script. So for example, say you want to print out the date based on a certain circumstance. Like you only want it printed out at if the user provides something or asks for it. An if statement would allow you to do this. An if statement will run a set of commands if certain conditions are met. I'm going to break down the structure of an if statement here. So the statement starts with the if keyword. So the next, after that keyword, the condition you're testing is presented, which is placed in square brackets. The semicolon is placed after the closing bracket, followed by the then keyword. Now, we put a semicolon at the end of the condition, and then you write then. So if this happens, then do this. And all the lines that run if the condition is met are indented by one tab space. Now, it's important to get your indentation correct in your script. After all the lines you want to put in your if statement are written out, you press enter, and on a non-tabbed line, you write the fi keyword. With that closes the if statement. I'm going to provide a little example of an if statement here. Let's say we have a variable. We're declaring a variable. We're making it equal num, or 1. So num equals 1. If. Now, in brackets, we're putting a condition. Let's say if num is greater than 0. Then, so if this is true, then echo $sign number, we're calling the variable, is greater than 0. And then we end our if statement with fi. So obviously, setting the num variable as 1, it's going to print this message out because it's true. 1 is greater than 0. Now, if we change the number to be like a negative number, this message would not print out. Now, the simple if statement like that works pretty well in a number of circumstances, but there are times where you need to test more than one condition. And that's where elif and else keywords are used. So the else keyword is reserved as a catch-all option if no other conditions are met. So you can test multiple conditions with if, and then every other condition can be elif, and then there's the else command. So for example, let's make a script that asks what kind of pet somebody owns. So we have pet equals octopus. We're just going to put something weird in there. So the script is written out to expect some normal pets like cat, dog, fish. So if pet equals cat, then I love cats. If pet equals dog, then I'm not really a dog person, all due respect. If pet equals fish, then cool fish. So basically, if this variable is set to cat, dog, or fish, one of these will run. So basically, because octopus does not equal cat, dog, or fish, these messages don't print. So the if statement is basically ignored. Since this doesn't pet doesn't equal cat, we move on to the next line and test that. Doesn't equal dog, we test this. And it doesn't equal fish. So the catch-all is else. So if you put something weird in there, it's going to say that is a unique pet. Like you can put chinchilla, you can put bear, you can put anything. You can put non-pets in here, and this catch-all statement that if none of these options match, none of these conditions are true, then this else statement's there to catch. It's just to print something out to the user. Now we're going to talk a little about for loops. Now these are used to repeat one or more lines of code. So basically, if you need to do something over and over again, a for loop is used. Now a for loop is also used to iterate over a list of variables or data values. I'm going to talk about how a for loop is created. So it starts with the for keyword, and right after that on the same line, a variable is created to store the data for each iteration. After the in keyword, which follows this data here, this variable we created, a shell command, list of files or variables, or an array, which is the equivalent of a list in bash, is provided. These are the items that will be iterated in the loop. So semicolon closes up the contents to be iterated over, followed by the do keyword. So the lines that run each iteration are indented by one tab space, is similar to a for loop. So the done keyword is written on with the same indentation as the for keyword, and that's used to close the for loop. Now here's an example of a for loop that has a little practical use. So it's used to delete all the contents of a specific directory. So for f in, so we're making this a variable. So basically we're running the ls command to list out every item in the /home/student/junk folder or directory. So f here is going to represent each file that comes out of this ls command. So let's say we've got like 5 files in here. We got junk file 1, junk file 2, 3, 4, 5. So for f in this, the output of this command do. So every time this runs, it's going to run remove, and this variable is going to equal 1 of the items in this ls command. So we got junk file 1, remove junk file 1, then it's going to run again, and again, and again, and again, for every file in this folder until they're all deleted. And then once the variable f can't equal anything, the loop closes. A while loop is used to repeat one or more lines of code as long as a specific condition remains true. Now this is a little bit different from a for loop, which is more for iterating over a list of things. So basically we set a condition with a while loop. A while loop is similar to an if statement where there's a condition to be met. So we set a variable here, and while this statement is true, then you keep doing the commands within the while loop. So while loops are very similar, or structured very similarly to for loop. I'm not going to go over this again, but basically I'll read out the example I've got. So basically I've made an example where a while loop runs until the user provides a certain number. Well, actually it's until this yeah. So while num is not equal to 3, do this. Select the number 1, 2, or 3. So basically a user is going to type out a number. And obviously we're not checking what number is being provided, but basically as long as this variable does not equal 3, this command will keep running. The user can just keep typing in numbers until the specific one is typed in. Case statements. A case statement is like an if statement, but simplifies the presentation of multiple choices. Now, we'll note in the second scripting lab, a case statement is recommended. You can use if statements, but case statements are actually a bit of a shorthand that reduce the number of lines you got to write out. So I'm going to talk about how a case statement is made. So the script prints out the options it wants to give the user. I recommend representing them with a number, like I'll get to the example later, but basically a user input is requested with a variable stored in it, followed by a semicolon. So the case keyword is then written, followed by the name of the variable for the user's input and the in keyword. So the lines that correspond to the options or options selected are indented by one tab space, kind of similar to how if statements and while in the loops work. So ESAC keyword is placed in the same indentation as the case keyword, and that indicates the closing of a case statement. So might be a little difficult to understand, but I'm going to try to explain it here. So let's say we want to ask people what their favorite pets are. So we have option 1, option 2, option 3. Option 1 is a cat, option 2 is a dog, option 3 is other. So we're giving people 3 options to pick from. So read choice. Now we're asking people to type in a number or an option. So let's just say people type in one of these numbers here. Case choice, and if we get a 1, we get echo, I love cats. If we get echo 2, I must not be a dog fan, due to respect. If we get 3, interesting. So basically we type in one of these numbers that we want to receive for the case. So it's similar to if statements. If you look back here, it's kind of similar to this if statement, but it's a little shorter, mostly. Now functions. So we're going to talk about functions. Not necessary for this class, but they are pretty useful. Because basically they allow you to create reusable code. So a function starts with the function keyword. The function is given a name, followed by a left curly bracket. So all the lines in the function are indented, like all the other structures we listed, like if statements, for loops, and so forth. Right curly bracket closes out the function, and then when you want to run the function, you run it like a command. So let's say we got a function here that says say hi. We have a left curly bracket. We tab our one line in the function. Echo hello CIT371 class. We close it with a right curly bracket. So if whenever we want to run this message in a program, we just run say hi instead of like writing this echo command over and over again. So a parameter is a variable that is passed to a function so it can be used by it. So more than one parameter can be passed to a function, represented by the following notation. So when we write a function out, and we put variables after it, they're referenced in order, starting with 1, 2, 3, and we put dollar signs in front of these numbers. So the position of a parameter in a function call determines which numerical notation it will be assigned to. So for example, if we want to say hi, and we have like variable, if this actually print out a variable, like say if we wanted to print out somebody's name, we put out one person's name here, we would call $1 here for the variable. And I have another example here that actually says this. So we have a function that's going to print out, hello, my name is this, and my pet is a what, or is it this? So we want the user, or we run the function by specifying the person's name first, and then the type of pet the person has. So we have 2 variables. We have name equals Bob and pet equals dog. So we type the message function, which is what we call the function. Right after that, we declare or we want to give the function the name variable and then the pet variable. We give the name variable first and the pet variable second because $1 is going to grab that person. It's going to try to grab for a person's name. It's going to be the first variable that is fed to the function, and then the type of pet is the second function or value fed to the function. So there is a lot more about Bash that I could cover, but due to time and just due to the scope of this class, I'm going to stop here. I've covered enough of the basics that should give you enough to learn how to script. Now, some supplemental resources I provided will go over these a little better than I did probably. We'll actually provide a live demonstration of it. But if you want more information, I do have some extra resources on the supplemental resources page. There's also some general internet research you can do. I just want to reiterate one more time. There are helpful video tutorials that will show you how to apply what I taught in these slides. Please be sure to read those because they will help you a lot in the labs. And, well, that's the end of the lecture. I thank you very much for your time. Hope you had a good time with it. I hope it helped you. Please feel free to reach out if you need help. And I thank you again. Have a good day.